Okay. Thursday. Nope, Friday. Sorry. Friday. What do we have? Yeah, I'm just going to move you a few seats over. Forever Never Final. And the mock AP corrections. Yeah. What's Friday? Oh, you're leaving this early? You're doing the morning one?
I don't know.
Okay. We'll figure it out. Thursday, though, is some of your guys' AP. Isn't there an AP Thursday? Psych, so I was going to be missing a few of you guys. But then I wouldn't be missing you, so I guess I could take it early. Sad. Okay, so Forever and Ever Final, be studying for that, and then the mock AP corrections. So we're going to pick up where we left off on Friday. Let me be opening that. LTF number 2, I passed out the full version of it because Logistic and Eulers, some of you might need that review, but to be honest, some of you just need to be studying your Forever's Endeavors. Some of you need to be practicing with FRQs, and the best place to go is just College Board and find the old ones. We've talked through all this, kiddos, so do what you need to do. If you're like, I can't just be given do what you need to do, I'm not going to do anything productive, come to me and be like, I need help doing what I need to do, and then I'll give you things to do, and it'll be great. I'm not like in a mean way, not in a bad way. Like I'll try to feel it out and feel what topics you don't feel confident about, and either send you to the AB reviews or send you to like just go grab FRQs from 2017, 2018, 2016. But we'll figure out like a little schedule, a little plan for you if you're like, I need help doing what I need to do. But our goal right now immediately is Wednesday, Saturday exams, the questions that you have on the multiple choice / the free response. Today you were supposed to hopefully have done FRQs 1 and 2. Was that the goal? I think. And then tomorrow, no, today was part B? I'm confused. I don't know. I thought I changed your board, and I kind of did, and I kind of didn't. I have tomorrow your Calc FRQs. I don't know. We're going to start in the mock APs and just see what questions you have. And you guys at some point should have the mock totally attempted so you can have questions for us to go over. There we go. We'll just say that. Yeah, I'm coming. I have Saturday. I have Wednesday. I have my calculator up if we have calculator problems. My very nice non-light up screen calculator. Oh, well, it works. And I think that's it. Issa, what's up, bud? Yeah, if you go back to LTF number 2 and if you do the whole packet, then because right now there was no bonus, right? It was just normal credit. So if you do the whole packet, submit it, and then it'll be bonus. Is that cool? It's bonus, so it's up to you. Yeah, because remember, it's the one we already did, but it was only partially copied before. So whatever was in the little baby packet before was the normal credit. There was no bonus available in LTF number 2, but if you do the rest of it, like the other parts to it, and then submit those pictures too, then you'll get the full credit and the bonus. Does that make sense? Yeah. Cool. 30th. Yeah. 29th is no finals because it's period 7 finals. Wednesday morning is the parent reception, and then the parent reception followed by graduation practice, followed by take a break, go get a nap, go get some food, come back for grad night. Parent reception, it's in the morning when everybody else is taking their period 7 final. Seniors take the period 7 final early, and it's breakfast and like a presentation, and I don't know.
Oh, do we all go to it?
Yeah.
And your parents go to it. That's why your parents can't go to it. Can you still go to it?
With what? Yeah.
You can't go. I was like, it's just the parents, but you have to bring your parents with you. Yeah, okay, no.
Yeah, no, you can still, because it's supposed to be.
Because we have graduation practice right after. Like, literally.
So it's like, come have breakfast.
So on Wednesday, we're supposed to wake up early, have breakfast, and have graduation.
It's not really early, it's just come into school.
Well, then we go home, That's too long of a day for me, guys. Yeah, I know. I just skip one of the
Do you wake early? Like, why do you have to wake up? It's just to come into school. Oh. Well, grad practice would be early if it wasn't for the other. Like, it's during normal school hours.
It's not mandatory, but it's probably like...
It's strongly encouraged. Like, it's the one time for you to, like, just you with your parents to be like, thank you.
Like, thank you for raising me.
So your parents might make it mandatory because they're getting information about it. It's up to you. But it is a sweet thing. Not long. Like 45 minutes, hour. And then you start graduation practice before, and like the parents get to get off campus before like all the crazy comes to pick up kids.
Do that at Shepherd?
No, it's just here. Everything's here.
Yeah, the graduation practice is here too. That's such a
Do you know how long, like, graduation rehearsal?
You guys should be done with graduation rehearsal by like lunchtime, by like noonish.
I need a shirt and then back, take a nap, and then start class. Let's just get you to that.
Yeah, or just go crash. You don't have to. Yeah.
I'm not even there. She'll leave.
Where are you going to be?
What am I gonna do?
Riley's like kicking her out of her own house. No, I get here. You go somewhere else. All right. Well, on that happy note, yeah, there you go.
What time do you have to be here for grad night?
I don't honestly know. I should know. I think it was sent home in the information.
Yeah, well, we're leaving here at
He said knows everything.
Oh, there you go. So we'd say probably 5.
He knows everything about
And you have to know about grad night because that's necessary for graduation.
We have like what, 2 more weeks of school? No, it's just this week and then next week and then
A half a week.
week and finals.
Finals start Thursday.
Oh my
And Monday is Santa Barbara of that week.
Wait, when is Tuesday? The 20th.
Okay. We have this week. We have this week. We have next week. We have Monday Santa Barbara. Finals start Thursday. That next Monday is a holiday because it's Memorial Day. And then you have Wednesday with like grad night and then Thursday graduation. Like you guys are spoiled rotten and teachers are freaking out. Okay, so because there's not much time. Right? Like you guys got this. It's fine. For the non-AP classes because you have kids in and out and then finals, like it's brutal. But it's okay. All right, cool kids. You ready? If you're totally bored, what could you be doing right now? LTF number 2 and it's bonus. Or, I mean, taking a practice exam probably is a bad idea. Yeah, but all I need for, good question about the other bonus practice exam. Test points, free test points. It needs to be attempted, graded, like marked right or wrong, and then I should see attempts to correct. Like I'm not going to go through and make sure you did every single one, but attempts to correct. Does that make sense? No. Just color pen in the thing. Yeah, just color pen in the thing itself. All right, I'm ready. I have Wednesday, I have Saturday. Just fire off questions. Where are we going?
Can we do part B?
Yeah, sure.
Okay, can we do part B on the
Saturday?
86 and 88?
Saturday, 86, 88. Ooh, that was an area volume-y one.
Yeah, this is the one where I asked you what isosceles right triangle was.
Yeah, and I gave you the formula for the equilateral triangle.
That's amazing.
You're welcome. Effort for success. Okay. Woo, isosceles right triangle. The AB kids had an equilateral triangle. You guys had an isosceles right triangle. What's the dilemma with them giving you that? Like, is it really that big a deal? No. If only they would have given you the geometry formula. Because that's not one that we're so good at. True? All right, so let's think about the shape real quick. Just because some of you could start randomly memorizing geometry formulas, like the area of an equilateral triangle is equal to square root of 3 over 4s squared. And that's only if all sides are congruent and everybody is an S. That's one way. But that's not this shape. Who's this shape?
2 sides are the same.
He's an isosceles. Wait, an isosceles right triangle?
Yeah.
Ooh. An isosceles right triangle, which means we have a right angle right here, and then we have isosceles right there. Which means I can call this A and I can call that A.
So then isn't that
1/2 base times. Oh, a kid just walked out. Well, this could be a squared plus a squared is 2a squared, and this could be the square root of 2a squared, which would be root 2a. Using Pythagorean theorem.
So then how do we do that?
So then area equals base times height over 2. Base is equal to root 2 times a times height. Ugh. Oh, but it's isosceles. This is cut in half. So we could take this guy up to the side. You're A, you're 1/2 of root 2A, and you're my unknown, which is my height. So now I can do A squared plus B squared equals C squared. Yeah, I guess so. That'd be 2 over 4, which is 1/2, right? So A squared over 2 plus H squared equals A squared. If we get it, then you guys can just write it down and then do what you're going to do. Minus 1/2 would be another half. Then square root, square root. So H is equal to A over root 2. What? So it's just 1/2 A squared? No. Is that really the geometry formula for an isosceles right triangle? Does that look right?
I'm looking it up right now.
Area of an isosceles right triangle. This is taking forever. How's yours going? Oh, there we go.
That's what I got.
Area, A squared over 2.
That's amazing.
Okay, so if you guys don't like these shapes, what could you do? Equilateral. Well, or just throw this on like your pre-cal card, even though it's not really pre-cal. That's your first card where you have the unit circle and you have like Pythagorean stuff. Right triangle, A equals A squared over 2. Because they don't expect you to like actually figure out the formula on the test. They expect you just to know it, which is really lame. Like you could figure out the formula on the test if you want, but anyway, at that point, Mal, you just throw it in.
Yeah, I'm trying. I'm going to put it in.
We could also go peek at it too. Because then at this point, you guys know when it's perpendicular to the x-axis that we have to go ahead and do dx, right?
Yes.
How do you know who's who if they don't tell you who's who, as far as which one's cosine and which one's the squared?
Just absolute values.
You could do absolute value in your calculator. You could totally do that.
Yeah, you get the right answer with this.
Okay, so we can go from 0 to 2 of top minus bottom being your A.
Yeah. And then you got to square it, and then you get the answer.
I'm just going to throw in that.
See if I wouldn't have the formula with that.
Yeah, I gave you the wrong one, Lucy and Tim. Actually, the cool thing is, like, it's one minus the other because it's top minus bottom. And usually, like, it does matter the orientation, but since it's squared, who cares? And on this one with your calculator, you could technically graph it and see which one's which. But yeah, top minus bottom. Is that good?
Yeah.
Okay, 86 and then 88.
Yeah. 88.
And then you have one ready for me after that, Riley?
87.
Oh, let's do 87 first then. 87
They tricked us.
says, suppose that the limit as n goes to infinity is infinity. Which of the following statements must be true? Guys, nth term test. Is this a good thing if the limit is anything besides 0? What diverges? Whoever has this guy has to diverge by the nth term test, because whatever, because the limit's not 0. So I know, well, that's fun. Would it be possible if you had an nth term test fail for an alternating to make it any better? Because doesn't that limit have to be 0 also?
Yeah.
Okay, so forget that. So now we're down to these three. A sub n plus 1 is greater than or equal to a sub n, which means that this is a decreasing, right?
Yeah. Well, it's increasing right now, but
It's a decreasing sequence.
isn't it increasing? Because a sub 1 plus 1 is greater than a sub n. Like it's always getting bigger.
Oh, I just read it backwards. Yeah. Did I say it backwards? So my series, there you go. If my series is increasing, what else does that take out? I was thinking D, because doesn't alternating, don't you have to have the limit equal to 0 and the terms have to decrease?
When I figured the answer is D because it's 1 over a sub n. So they say the limit as n goes to infinity of a sub n is infinity. So if you put 1 over infinity.
The limit is 0 and the alternating says it's good, yeah?
Yeah, and then if you put 1 over a sub n, that's going to be greater than 1 over a sub n plus 1 because 1 over a sub n plus 1 is greater than a sub n. So then it's going to also decrease. So then the alternator would converge.
Yeah. So we're thinking about 1 over infinity equaling 0, basically. And so since the limit is 0, we don't know for sure. Remember, if the limit equals 0, we know nothing, right? So technically, we don't know enough for C. And then A, it's like, well, it could be convergent. But then why is this one necessarily true? That's why Maggie was starting to talk about the 1 over a sub n plus 1. Which to get that, we could do a sub n plus 1 greater than or equal to a sub n. We could divide by a sub n plus 1, which would put it on this side. Then we could divide by a sub n, which would put it on that side of the inequality, which is how we can see our decreasing as a result of this guy originally increasing. And so since the limit is 0 and the terms are decreasing, then the convergent one. And basically these ones are we know nothing, so we can't say for sure must be true just based on the limit being 0. Because it could diverge or it could converge, but definitely this one's okay since the limit is 0 and the terms are decreasing. But yeah, that one was messy. Vectors, yeah? Can I get rid of this? Hold on, because he's just horribly out of whack. Okay. How far is the particle from the origin? I would just figure out what the position, what the particle's position is, right? Because how far is it from the origin? If you just do displacement, you're just going to know how far away from this point it is, but you want it from 0, 0. If you find total distance traveled, that could be like boing, boing, boing around the origin and ending up like at the origin or really close to it, even though there was all that distance traveled. I think you need to go, and this was what you guys missed on the Chapter 11 test, a lot of you, to find the position. Why do you hate me today? The position. No clue what the difference was. Anyway, 1 plus the integral from, where are we going? Oh, 0, thanks. From 0 to 1 of 3 dt, so you're doing your x of b plus the integral from a to b of x prime of t. Remember, he's your x prime, and he's your y prime, comma. And then we can do our 1/2 plus figure out the change. So starting at our initial x and our initial y. And then our change from 0 to 1 of 2 to the negative t squared dt.
See, I thought about that, but I don't know how you get like one value. Yeah, that's why I went to
Magnitude.
I started doing that and then I looked at the answers and then like.
Let's double check though. But my guess is distance formula. Because wherever you're going to end up, you're going to have an x and you're going to have a y, right? Because then we can, there we go, we can throw in our x initial was 1, and then we have our 0 to 1 of 3 dt, which I should have just solved that because it'd be faster, but that's okay. You end up with 4. And then you have your 1/2 plus, remind me of that weird guy, it's 2 to the negative? Who's that? Negative t squared. I know I typed something wrong. Lo siento. There we go. Okay, so then we have 4 and 1.31 dot 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 dot. So what does that mean? Yeah, you do. It's a position. How far from the origin? Does that make sense? So you have your x and you have your y, and ultimately all you're needing to do. I said magnitude because that's what we've done most recently with the distance formula. But yeah, basically. Well, let's make sure it works, but that's what I would have done as far as how far, because how far is a diagonal distance. So then I think we can go ahead and just do the square root of 16 plus that nasty dude squared, which ends up being 4.209. Got him, coach.
Okay, so basically, hold on.
Yeah.
Catch me if I'm wrong. We can use the total distance traveled, but I just have to add the initial point. Isn't that basically
But the total distance traveled, careful, is taking into effect the positives and the negatives and adding those up. So the idea is this guy could have bounced around, if I get back to my picture, wherever he is. This guy could have bounced around. We didn't actually graph him. Where did I draw him? Oh, here. He could have bounced around and ended here. So if you do total distance traveled, you very possibly could have the length be much longer if there are positive and negative displacements.
Okay. So you just find the position and
Yeah.
then you do the distance from 0, 0.
Yeah. Yeah. If this was polar, it'd be a little different because they would say how far from the pole, and that's just who r is. It's no big deal. But this one, the x and y, have to combine it to get the hypotenuse.
I also got,
Saturday?
wait, I think I asked you about 8 and 9 already.
Did we answer? Oh, I think you might have. But we can think about it. The second degree Taylor polynomial. No, I don't think you did. I don't remember talking about this one. As soon as I see second degree Taylor polynomial, I'm going to start building it, right? Then forget about the graph until later. So building it, I have my f of 0 plus f prime of 0, centered about 0, which is what I kept messing up on last week. X plus f double prime of 0, all over? Hi, girl. And then I'm done? Okay. So I can say 1 plus 2x minus 2 over 2 will just simplify. I need a downward parabola. And here's dilemma A or B, right? So hold on. If we have this guy as our downwards facing parabola. Ooh, do they both have? No. Check out this dude's max. He's somewhere in between 0 and 1, and this dude's max seems to be more around 1. If I were you, I would have set this guy's derivative and found my critical number as to where my max should be. But was it mean that they didn't show the parabola? Yeah, that was nasty. But it was all about where the max was.
I also got
90?
Yeah.
The alternating series. Ooh, p is equal to 1/2, which normally diverges, huh? That's random. Based on the alternating series error bound, what is the least number of terms in the series that must be summed to guarantee? This is like, this was before Lagrange, before Taylor and Maclaurin, when we were talking about alternating series in chapter 9. You guys, when we were trying to find n, that's exactly what this is. We're trying to find n, the number of terms that guarantees. So to that end, we have to think about the alternating series remainder theorem. Yeah. We've been doing Lagrange so much. which says, look at the next term. Oh, not again. Why do you hate me today? Isn't that the alternating one, where it's just going to be less than the next term? So then I would set up an equation. Now, absolute value, I can totally ignore the alternator. So I'm thinking about 1 over square root of n plus 1, and I'm thinking how that has to be less than 0.03. Because this is talking about the actual, and this is talking about the error. So if it just says a partial sum that is within 0.03, that's just talking about error. So the error is less than this guy.
Wait, is it switch? Like, is it a...
It says within, so if this is within that, then the error will be within. Sorry, I didn't finish writing it. Is that cool?
Yeah.
So we're just putting him as our boundary.
Is it always like that, or does it depend on the word?
I can't have this go the other way, because then the error could be somewhere in between and I wouldn't know. So I have to have it be on this end to be safe, or to be guaranteed. So at this point, I think I would just rewrite him. My brain likes fractions better, so I would just make this 3 over 100. Then I would multiply up and then go the other way, so I'd end up with on this side, and then 100 over 3 on that side. Doesn't look super great. Maybe I should just go to a mixed number. 33 point something, something, something. Wow. So I can go ahead and divide in. I end up with 9 goes in, 1. Oh, this is 1 minus 1? That'd be 1110? Are there decimals I didn't think about? 111. Oh, yeah. I just ran out of room. 1, 1, 1, 1, and 1/9. 1, 1, 1, 0, and 1/9. And n has to be greater than that. There you go. So the smallest whole number, because n is only integers, right, will be 1,111. Yeah. I didn't think to put the 0.1111, the decimals. But see how much I had to keep track of those inequalities? Like, otherwise you could have gone the wrong way. Except, looking at their answer choices, if they're really going to be this nice, and this is the most recent practice exam, if you were close, you'd be fine. Maggie and Riley are just grabbing the floor because they have questions to be answered. Does anybody else want to throw in something? For A's or B's, Saturdays or Wednesdays? You guys fine just following them? Okay. Maggie, keep going.
A on the Wednesday,
Okay.
16.
Wednesday exam. A lot of you guys took this Wednesday exam, so A16 is where we're headed. Did you do product rule with the chain rule?
Yeah.
Good. So hold on. Trivet the outside times the inside. And then second D first plus first D second. Okay, here's a question. Did you guys get dy dx by itself, or did you plug in?
Well, I tried finding dy dx by itself, and then that didn't work, so then I tried.
I think it would have saved time plugging in first,
Yeah.
right?
I think it's all messy.
Yeah, but hold on. So this is pi over 2 times 1 is just pi over 2. So we're going to go unit circle in a sec. And then we have 1 plus dy dx is equal to dy dx. I just need to get a number. So then sine of pi over 2, you guys do your own way, but me, I know where pi over 2 is, and so it's going to be 1 with a negative, right? So then 1 plus dy dx.
I had an extra x in my derivative.
Oh, you did? Second d first plus, oh, I'm dumb.
Yeah, there. So
I'm
that's
dumb.
what I
First d
had.
second. I did it too fast.
So then I don't know how to do dy dx.
Where are the pies coming from then?
Yeah, no. Because then pi over 2 got plugged in.
Yeah.
I'm still going to move my negative to the other side, though, if that's okay.
I'm tracking.
It had to happen eventually. You got to get dy dx on the same side. Yeah?
Yeah.
So then can't we pull out a dy dx because the negative 1's going to have one and the negative pi over 2 is going to have one?
Oh, you subtracted that to the other side.
I subtracted and pulled out the dy dx.
Okay, I see what you did. Okay.
And then technically, I think I would have pulled out a negative 2, if that's okay. Then divide that to the other side. Well, divide the negative and then divide. Come on, use my trick. What's my trick to simplifying complex fractions?
Just multiply by the denominator.
Or you can do a common denominator of 2 over 2 and flip that 2 up. Or you can multiply top and bottom by 2. So you get negative 2 over 2 times 1 is 2, and 2 times pi over 2 is pi. So I get a 2 plus pi and a negative 2b. There you go. So divide that, simplify the complex fraction either by common denominators and dividing by a fraction is multiplying by a reciprocal, or just multiply top and bottom by 2. We're on the Wednesday exam. I don't mind still being on the Wednesday exam, or we can flip back to Saturday. Wednesday?
17, 18, 19, 20.
Do it. It's okay.
Yeah, I got those all wrong.
17 through 20. Anybody else want to raise a hand and say, yeah, I missed some of those? Yeah. We have some nice forever cards in here, though. People who are studying their forevers. Number 17 says average value.
Whoa!
All right, Diva, what's the average value formula? It's okay. I have to close it and open back up anyway. You can think for a second. The average value of F formula. She's got it.
Average value.
Minus a,
Yeah? Times?
the integral, right?
Yeah?
A to b, f of x.
You got it.
She just schooled you. I just flex on Issa right now.
I bet Issa didn't know that.
I knew that.
Issa, name Rolls theorem right
I just
now.
flex.
We got it?
Rolls theorem.
Oh, don't do... Shh, come back. You don't even need rolls. You just need MVT.
Then there exists a function at x equals c such that f
Issa,
prime
how do
c
you go from
equals
polar to rectangular?
oh, why is ours? Why is ours like
I'm going to start solving. Okay, so
I know my first.
1/2. Are we cool with ln of 6 minus ln of 4?
Yeah.
Do we know log properties? Woo! Because subtraction of logs is division of the arguments. Nasty. You see it? Because it'd be 6 over 4, which reduces to 3 over 2. But that's one of, no, it's not. I mean, pre-cal.
I got tricked and I did 6 minus 4.
Well, it was waiting for you, wasn't it? It was right there to confuse
I
you.
was like, oh, that's so easy. I'm so good at calculus.
Which you were. You did all the calculus and you messed up on the pre-cal. It's a struggle. Second degree Taylor polynomial 4. About x equals 3. What can we not use?
Not.
We can't use the special Maclaurens. Telling that to myself more than you guys because Arian caught me on it last week. Okay, so second degree. Don't I need f of 3 plus f prime of 3 x minus 3 plus f double prime of 3 all over 2 factorial times x minus 3. How are we doing as far as the general formula? Okay. F of 3 would be e to the negative 6. Wait, is this literally the one we did last week that I totally messed up?
Yeah.
Go team. Does anybody still need that? Did you get it last week, Riley? Number 18? Okay. F prime, because of the x equals 3, about, we can't use a special Maclaurin, so we're going to have to literally find derivatives of. But it's okay, we only need 2. So plugging in 3, I get negative 2 e to the negative 6. And then I get my f double prime would be negative 4 e to the negative 6 all over 2 factorial is 2. Which is a bit nasty, but what are they asking for? The slope of the line tangent. Well, if this is my p, slope of line tangent, don't they want my p prime? So p prime derivative of that guy is just going to be 0. This guy, I can bring down my 1, so my negative 2 e to the negative 6, and then that all cancels out times u prime is just 1. This guy, I have to bring down my 2, that cancels, negative 4 e to the negative 6. X minus 3 to the 1 times u prime is just 1. And they're asking about at 3. So at 3, 3 minus 3 will cancel. Yeah, and all I have left is that dude. Yeah, my explanation last week wasn't great because it took me like 5 minutes to figure it out. Number 19 and 20.
If I knew what graphs look like, I think that would have gotten 19 right.
Do you need a graph for 19?
Well, no, but like you would know it's odd by just saying graph.
But the other way that you could have done it is, like, let's say they don't give you an obviously odd function, right? Couldn't you have actually, like, solved? Is that equal to 0? Because then you would have had 2 to the 4th is 16 over, you would have had 4 minus 1/4 x to the 4th equals 0. You could have subtracted the 4, multiplied x to the 4th equals 16, x equals plus or minus 2. Or you could have thought about how it's odd. But either way works. Either way works. Now we have parametric functions. But wait. We know that dy dx, the slope of the tangent line is just y prime over x prime, right? At t equals 1. And for the tangent line, we just need y minus, now careful, parametric, f of a is going to be y of equals dy dx times x minus, we can't plug in the 1 directly as an x or as a y because he's a time. So we plug in to find x and find y. So my y prime would just be 3t squared plus 5. X prime is 2t, t equals 1. Y of 1 is what, 6? X of 1 is 4. I'm doing it fast, hope I'm good. And then plugging in 1, that's going to be 3 plus 5 is 8 over 2, which is 4. So 4x minus 16 plus, is it b? But you just have to simplify. You have to do that number crunching. Nice and careful. That could, it's up to you guys, but that could, I don't think we actually wrote out a tangent line for parametric equations. You could go to your parametric card and write y minus y of t equals, I don't know. That's up to you. Sorry, oh my gosh, I heard sad signs. Yeah.
Yeah, I need 22. So
Okay. These are both on series. What do you guys see? Radius of convergence of 2. Okay. Do you guys check? Do you see this guy right here? What does he tell you about the about? This was a key to one that Maggie asked last week that I didn't notice. What does x minus 5 tell you about the about? It's a power series. All power series are about, centered around, right? Isn't this about 5? Right? So if it's about 5, and if I have a radius of convergence of 2, then question, what would my interval of convergence be? Wouldn't it be between 3 and 7? Because I would do 5 plus 2 and 5 minus 2. If you can look in and see like, oh, hey, it's about 5, I can see that because it's x minus c or x minus a, whatever variable we're using. So that power series is about 5. Go 2 up from that 7. Go 2 back. That's 3. But hold on. Don't we have to check, right, at x equals 3 and at x equals 7? Okay. How do we do the ats? How do we test? I'm testing for the convergence as to whether I put parentheses or brackets at the endpoints of my interval. But saying at which of the following values of x can the alternating series test be used with the series to verify convergence at? I knew I was going to lose it. If it's not inside the interval, to verify. These ones aren't inside the interval. Yeah. So the only ones that could be verified that this says, now I would have expected 3 and 7, but they probably thought that would have made it too easy because then you could have figured out. So they went ahead and said verify convergence because the interval of convergence says everybody in between is okay. I was going to go for 3 to 7, but 6 minus 5 isn't going to be a negative, so forget him. 4 is the only one that works. Double check it's B. But, yeah. These ones diverge because they're not in the interval at all, and instead of giving you the endpoints, and because it would have been at 3, that would have been the alternate. And then I would have looked and seen that it didn't match, and I would have been like, oh, hey, who else isn't alternating? But, yeah. Good call. But if you guys notice, any of these plugged in would have been alternating too. So it had to be already convergent to be verified. About 0.
I couldn't match it to the a sub 1 over 1 minus 5. I don't know how to do it because it's 2 instead of 1.
So if worst comes to worst, couldn't you start taking derivatives?
Yeah, that's what I did, but I got all my derivatives wrong.
Okay. Can I do first the a sub 1 over 1 minus r? We could do...
First one, and then I started writing at the open here, and then crossed it all out.
I wasted so much time doing it, and then I get a number that doesn't even match any of them, and I was like,
That's how you could have done it. Double check though, because it'd be 1 minus negative 1 plus 1 is 2, and then minus a negative x would have been plus x. But if that didn't work, like your brain's tried to make it match a sub 1 over 1 minus r, if it doesn't match, okay, fine. So let's check it out. So x cubed, the coefficient should be, right, the triple prime of 0 all over 3 factorial?
yeah, but it's so hard to take that.
Let's check it. It's not hard if you rewrite. It's not as hard if you rewrite. I apologize. I get it. I get it. So f prime, couldn't we just do power rule?
Yeah.
So bring down a negative 1. It's going to be to the negative 2. Well, forget it. I don't need it to look pretty, do I? Negative 1, 2 plus x to the negative 2. Isn't u prime just 1? So can't I keep doing power rule? Bring down the negative 2 to negative 3 times u prime. It sounds like you guys started getting like nasty product rule, quotient rule stuff, but you didn't need to. And then put it over, plug in 0, put it over 3. Well, if you can make it match, yeah, it's not bad. Yeah.
The corrections, are we just writing
Color pen in it. Yeah, no papers, no papers.
over 3 factorial?
Yeah, so I would get negative 6 over 2 plus 0 is just 2, so 2 to the 4th times 3 factorial. That should be, oh, 3 times 2 times 1 is 6. Forget that. And then 2 to the 4th is 16. Got it. Got it. Riley, you also wanted 21, 22, 23, 24? Okay, because I could have kept recording. Sound good. Kiddos. We're kind of doing like A's and B's of Saturday and Wednesday. We haven't gotten to B's of Wednesday yet, so I don't know. Come tomorrow with questions. Cool? And if you're like, this isn't what I need, then bring headphones, put them in, and do practice tests during my class. Do what you need. It's okay. Study forever. Take practice tests. Print off FRQs from previous years. If you give me a whole set of FRQs, it's half of a bonus exam, 2 points, 2 free test points. An AP College Board, they go all the way back to the 1970s. Don't do those. Do the ones in the 2000s at least. Bye, guys.